In this video, we're going to try to factor a 12th degree polynomial, in this case x to the 12th plus 10x to the 6th plus 25. But we're going to do it using a form that we have learned in our quadratic work, in our binomial work. So in this particular case, the form that's floating around in the background is the perfect square trinomial form. In particular, a plus b quantity squared is equal to a squared plus 2ab plus b squared. So that's the form we're going to use as motivation to be able to simplify or factor down this particular polynomial. So we have x to the 12th plus 10x to the 6th plus 25. And if we're going to use this form, then we have to break it down to make it look like it's in that form. So I'm going to take that x to the 12th and write it as x to the 6th to the square. And that's the a squared plus, with the 10, I want to make it into a 2 times a times b. So I'm going to write down a 2. What do we multiply 2 by in order to get 10? Well, that would be a 5. And then what do we multiply by, or what's the only thing left over, I should say, is just the x to the 6th. Plus, on the end we have a perfect square also, because that's a 25. So on the end we have a 5 squared. So now if we look closely, you'll see that it is actually precisely in this perfect square trinomial form. We have something squared on the front and the back, namely x to the 6th squared and 5 squared. And then in the middle we have 2 times a times b. We have a 2 times a 5 times an x to the 6th. So that means overall this would break down into, or factor down into, the first thing, x to the 6th, plus the last thing, 5, quantity squared. And so that's how we can factor this 12th degree polynomial, really only using the techniques of squared binomials, or in general the quadratics. So I encourage you now, why don't you pause the video and see if you can do this second example on your own. And assuming that you paused the video for a moment and attempted it and got an answer, let's see if we did it the same way. So this time I switched it up a little bit. We're still going to use a perfect square trinomial, but this time it's a minus b squared due to the minus sign. This form was a minus b squared equals a squared minus 2ab plus b squared. So let me box that up there. That's our motivation. So how does that motivate us here? Well, with the y to the 10th, I'm going to rewrite that as y to the 5th squared. 12, I want a 2 in the middle, so I'll put a 2, and that would have to then be multiplied by a 6 to create the 12, and then we'd have a y to the 5th. And then on the end there we have a 36, which is exactly a 6 squared. So you can see how the role of a in the formula is being played by y to the 5th, the b is being played by 6. So the factored form using the formula for the perfect square trinomial would then become y to the 5th, and then it would be a minus sign with a 6, and that would be squared. Hopefully you got the same answer.